Our guest speaker is Mehdi Boromand, a geospatial technology specialist with more than 30 years of experience working across surveying, reality capture, BIM, and digital twin technologies. Throughout his career, Mehdi has worked at the intersection of physical space and digital representation, helping architects, engineers, and infrastructure teams better understand, document, and manage the built environment. His experience spans laser scanning, photogrammetry, UAV mapping, SLAM, mobile mapping, and immersive spatial technologies, with a strong focus on translating real-world conditions into usable digital environments for design, coordination, renovation, and asset management. Mehdi previously worked with Bentley Systems in digital twin and reality modelling across Australia and New Zealand, and currently leads reality capture initiatives with Scan-Tech Surveys in Melbourne. Today's session will explore how emerging workflows from scan to BIM to immersive virtual tours and digital twins are changing how we capture, interpret, design, and interact with architecture and space itself.
Thank
Thank
you.
you, Mehdi.
Thanks, Alina.
Thanks, Amin.
Great voice.
Thank you for your intro. Can you hear me okay?
Yes.
All good, awesome. So yeah, this is really a privilege for me to be here as presenting and share some of my thoughts around the topic, which is from BIM to digital twin. Thank you for introduction, and thank you, Amin, for arranging this and organizing this. So I assume that the audience is more architect, the students in architecture, and also some professors around. And this is really a privilege. I need to learn more. It's also a learning curve for me to be in this space with the architects sitting around. So I hope that it's going to be more interactive session rather than being a monologue speaker. So feel free to stop me, interrupt me wherever it makes you have questions, and then we make it more interaction. So probably, hopefully, will be some real content and some educational content and exchange, and we'll learn from each other. So hello everyone again, and thank you for having me today. So as the title suggests, this session is, as I said, about the journey from BIM to digital twin. For those who knows what BIM stands for, well, you're already proficient in this space, building information system, or sometimes building information management, or building intelligence management, or building insight management, whatever you call it. The idea behind is how we do this intelligence creation around the building and construction. So as the title suggests, this is about the BIM to digital twin. So, but I would like to also frame it more broadly. This is not only because this session is not only about the software models or technology. We try to make it more about the how we understand the buildings and how we document them, how we coordinate design and construction, and eventually how we operate them more intelligently in a smart way. So for architecture, that is my prime focus in this session. I try to tailor the content revolving around the architecture, and this is becoming very important because buildings are no longer just physical space. They are becoming very connected, measurable, and data-informed environment nowadays. So I will share both concepts and some practical examples from my own projects that I've been into, and from the reality capture, transforming to Scan-to-BIM, virtual tours, and digital twin workflows. So I try to turn on my laser pointer. You see my laser pointer? Okay. And Yeah, this is going to be the agenda of today's session, following a simple journey that we're going to share. First, I will briefly introduce the industry context and a little bit about my background. So then we move to the CAD and to BIM and digital twin and explain the differences between them, how we differentiate them. And after that, we will look at the concept to BIM, scan to BIM, and what they mean, especially for new construction and or existing construction of buildings where we have renovation, retrofit, and sometimes heritage projects, how we restore them, do the restoration. Then I will show how reality capture technologies such as LiDAR, laser scanners, drones, SLAM scanners, any mobile scanners, 360 panoramic spherical cameras support design coordination and existing condition modeling. And finally, we will connect all of these to a digital twin, how we put together in a seamless, hassle-free workflow and life cycle intelligence. This is going to be eventually the deliverables, the catch, what the values that we are creating, and ROI, the return on investment, and for the industry. So, makes sense? You resonate with what you're looking for? So I cannot hear anyone. So probably you're all are on mute.
Oh, sorry.
Right?
Sorry,
No
Mehdi. That looks very good, but please
Okay.
apologize us if we ask some questions. We might not be familiar with some of these words. But
Yeah, sometimes I try to measure some feedback, so it's nice if you keep the mic open, or because I do not.
yeah. I just realized my mic is off.
Yeah.
So yes, we
Yeah,
can
sorry.
ask questions, and I will let the students
Yeah,
to
at
ask.
least from this room, if I from time to time I might ask some question to measure the feedback, how it makes sense,
Yeah,
or it's good. Okay,
that's very good. Yeah.
perfect.
All right. Yeah, you can keep
So
going.
I move forward to the next slide. A little bit about my background, just about a few words. I have been working for more than 30 years in this space across surveying, mapping, geospatial technologies, reality capture, as you can see in the screen. I'm playing with the laser scanners on tripods, on mobile mapping, and also you see this, launching a drone over a bridge. So, and BIM related workflows. You see me in this town hall station in the Melbourne CBD, scanning on the boat on Yarra River in Melbourne CBD, scanning the bridges, and you see these bridges. Launching the drone in Melbourne CBD, both fixed wing drones. So in practice, this means going to the field, capturing the reality condition of a building or site, processing that data, and transforming into something useful for architects, engineers, contractors, asset owners, and decision makers, and contractors. And so in the recent years in Australia, I've worked with the drones, laser scanners, SLAM, and this is just a glimpse of what I've been doing over the past 4 years. So today I'm not presenting only from the theory, I'm also sharing some of those stories. And this is me on the stage last year for Smart City Expo, fostering the technology of digital twin at city scale. So this is going to be the end of this session today as one of the takeaways. So that was enough about my background to give you a sense of what I've been active for. So what does digitalization matter? Why it's important? And it's not digitalization for the sake of digitalization. We don't do this only to be just to create a fancy material. The real value is that buildings and infrastructure are becoming smarter, more connected, more sustainable, having more resilience actually. So in the past, many decisions were made based on drawings, assumptions, site visits, very fragmented information, and so friction in connecting them, and there were so many hassles in it there. So today, with the better digital workflows, we can make decisions. Sorry, let me close this window. A little bit noisy here. So with better digital workflows, we can make decisions based on clear information. So clarity over assumptions is really the value we are looking for. Some measurable reality, better coordination between the teams across the construction and also the operation of the life asset, the many different teams, how to align them and how to be in relation with in a collaborative environment. This means saving a lot of time, reducing cost, improving quality, reducing waste, improving safety, and supporting sustainability. Or in simple words, digitalization is helping us to do more with less. As you know, nowadays, because of the labor, also the shortage in the labor, also this really makes sense in terms of how we can do with less resources. So less also rework, less uncertainty, less wasted material, and better long-term outcomes. How we can increase the efficiency around the project lifecycle. So this slide shows the evolution from CAD. So I remember that 40 years ago when the AutoCAD came to the market. So till today, the evolution, I was witnessing the evolution from CAD to BIM and then to digital twin, and how they transformed in this, and they were evolving along the way. And CAD was a major step forward because it's replaced manual drafting with digital drafting in more inline works, of course. But in most cases, CAD was still mainly line and layers and drawings, more line works, rather than being more 3D context. So then BIM changed the game as a game changer. So a wall was no longer just two lines in the 2D maps. It became an intelligent object, material with thickness, even this vendor, supplier, all information connected to that specific wall, height, relationship to the other elements, and other information really started to shape the BIM and what the value in it. So BIM is not just 3D, not a 3D geometry that we get. We simply just convert the 2D to 3D in the CAD model. A 3D model without information is still just geometry. BIM combines geometry with data. So digital twin takes this one step further as the next tool to actually to live operational data that you need, like how to connect the sensors and monitor the system. And this is really shaping the what we call as life cycle intelligence, or the project intelligence. So BIM helps us design and coordinate. Digital twins helps us monitor, operate, predict, and improve performance over time. Make sense?
Yep.
And yeah, this is just a step level from 2D to 3D and BIM, and eventually the digital twin. Try to put in the slides. So basically, we start from 2 points. Either we have an existing building, we want to do renovation, we want to extend, add another extension, we want to reshape the facade or change the interior design or change the use. So for those cases, we are considering an existing building or an existing infrastructure or structure, let's say. This is where we need to know what's existing on the ground in reality. And so what we call it as an as-built map is really crucial here to be to have more clarity rather than having assumptions and then making mistakes not pretty much aligned with the existing situation. Or we start from the scratch, from the concept, drafting on a paper, and then the sketching, and also the designing eventually as the first step. So this part is, I just split into origin of the data that we are providing and feeding the system, and the rest, they merge together into, and we end up with the BIM model. So in those cases, we do not start from imagination. We start from a reality, the scan. So we scan the building, capture the existing condition, and then create a BIM model based on what is actually there, rather than assuming or just guessing. This is very important because many existing buildings have missing, outdated, or unreliable drawings. Even for those who have these maps, we can simply consider those unreliable, or we want to double check and verify those documents. And sometimes it takes much less if we do everything from the scratch and map the existing situation as the as-in map. So Scan-to-BIM brings clarity over assumptions, and it reduces the risk before design begins if you want to do something. So this is also in the lower part of the slide showing the different phases of the actually life cycle of a project. Planning, starting from planning, either it's coming from the concept or from scan to design, and then we start to do the construction, the building part. So either again the renovation or remodeling, reconstruction, or adding some stuff, and then how we operate them. So normally this stage is like 5% of the whole project lifespan of the project, like a couple of years, and then we operate the asset like 40, 50 years, half a century. So this is really crucial, and how we feed the system. Eventually we'll have a digital twin of the assets, and I will come back to this definition of the digital twin and try to demystify some of the misconception there. So, but for this, because we normally develop what's the best scenario in terms of the best practices or playbook or the blueprint of how we should do the reality capture, what devices, what technologies, what methodology we should use for what accuracy. So when it comes to the reality capture, the LOD matters here. So LOD, as you already know better than me, that LOD stands for the level of details or level of development. Again, so it's simply actually reflecting the level of details, and as you can see, I try to put this in one slide, starting from LODT, which is a simple box. So when we're talking about the BIM, one important concept is LOD, as I said, and it's sometimes misunderstood, and only the thing that people might think that it's only visual detail, but it's more than that. It's really about how reliable and usable the information is at each stage. And what we expect, this is really standardized already. At early stage, such as LOD 100 and 200, the model may represent the concept, massing, approximate size, and general location. At LOD 300, so the model becomes more suitable for detailed design and coordination. At higher levels, such as LOD 350 or 400, the model supports construction, coordination, fabrication, and installation. It has to be super accurate for the installation and also fabrication, super detailed. LOD 500 is usually associated with verified and built information and facility management as well, and that's the final stage, and is usually associated with everything verified, and also reality capture. The key question is always what level of accuracy and detail is fit for purpose. So when we start to receive a project, the scope is really shaped around the expectation and what stage is really the asset owner or the contractor is expecting us to deliver at the end. And we are normally at the moment with the existing technology that we have in reality capture, we are between in LOD 200 and LOD 300. Just from LOD 350 and beyond, the other MEP aspects, the mechanical, electrical, piping, and HVAC systems, everything will be added to the system, and we are still having some weaknesses around how we capture them accurately with the required actually, and how to fulfill and meet the requirements in terms of the accuracy. So at the moment, we do not claim beyond the OD 300 in terms of the reality capture. Any questions so far?
We have some questions, but would we ask the questions now in this stage or like all at the end?
Okay. We'll just make a note not to forget.
Yeah,
we
but
can do it at the
if
end.
you want, we can ask the questions now.
Well,
So
feel free if you think it makes sense we do it on the fly. So of
Yeah.
course that will be a bit more challenging for me to do the time management, but yeah, feel
Yeah.
free. If for
No.
a couple of questions, no, not a big deal.
But just a note, Mehdi, just that this page is really indicative of the information our students, particularly for the EBS students, environmental building system students, I feel that this page could be one we could maybe come back to at the end because it's quite informative for their program.
Oh, it's good. Yeah, I'm really glad that it's good to know that it resonates with the audience and in terms of the values. So we can come back. I can even share this content with like a YouTube that I've already prepared. I will share the YouTube link at the end, so you will have access to come back even if our limited time does not allow me to cover some of the answers. So that might be also good as well.
That's
okay.
great. It's superb. I mean, just even the placeholders column is so important for our students to think about because they have so much to think about. But as soon as you say placeholders to them, they'll be able to compartmentalize from that point on, which is superb.
Perhaps I need your help at the end. You should join me and help me replace me to cover some of those if it makes sense.
Thank you.
Thank you. So if you allow me to go to the next, I tried. This slide. I know that it looks a bit noisy. Sorry about that. But what's important, I'm trying to highlight some of the key aspects of this slide, and this brings a full journey together in reality, because we are not only those two points to start. I mean, the concept to BIM or Scan-to-BIM. We have something hybrid in between, and this is where we start from the scratch, from the concept, and when we start to build and do the construction phase. But during the construction, we really need to do this reality capture with the frequency. So frequently we do like a monthly or weekly, depending on the complexity, depending on the type of the project. So at the time interval, we do this reality capture, reflect the reality, and looking back to our project progressive documenting, how we document this and how to align to make sure that we are tracking the project, to make sure that we are on time and budget. And this is pretty much how sequencing matters, and how in terms of the planning and how we track and monitor the progress. So this is the box I just put in between these two as the hybrid part of the concept plus Scan-to-BIM altogether, and what it means here. So yeah, this is a Scan-to-BIM. I'm trying to spend a little bit more time because it's a bit informative. I'm gladly to know that's resonating. So many projects, new building may start from the concept, but during construction we can scan the site regularly, as I said, for example, monthly or at any milestones. This creates a record of reality progress, and not just reported progress, because we have on papers in terms of planning, but we are not make sure that we are aligning and we are following, or we are behind the schedule or ahead of the schedule. This is really crucial to know. So it allows the teams to compare planned versus actual construction, identify delays, even detecting the clashes if something happens, or check the quality and support this clash detection. As I said, over time, these scans become also historical layers of the project and the digital twin, the history of the digital. It's really nice to have in layer. So for example, each monthly layering is really a time lapse showing us when we go back, travel back through the time, we have this time lapse, which really makes sense. And we have the timeline of the project, and each like a time lapse. So this is very powerful because the building gains digital memory. So this could be considered as a memory of the project. So just imagine that 10 years later in operation, something happens and we have everything's covered and buried, and we need to know how it's built up so we can go back and restore this memory. And through the time lapse, we can identify what happens wrongly or with the problem. So later during the operation, this information can support the maintenance and asset management, retrofit, and digital twin workflows. So I did not dive into the, I dive very deeply.
I can't hear him. Oh,
Someone hearing something?
Emily, did you have any question?
Maybe mic was on, right? Okay.
Yeah.
So from this slide, I try to play some videos, a little bit more visual, pleasing content, because probably before it's getting boring for you, I try to please you more and a little bit refreshment. So this is how we Scan-to-BIM means in practice. This is one of my projects in Perth that we've scanned sports facilities in Perth. This I put together in the Twin Motion. Perhaps you're already familiar with this Autodesk product, which is for visualization and animation. So I put together, this is the point cloud I just got from the different projects. And how we do the Scan-to-BIM is simply meaning that how we replace the point cloud with the Revit model, for example. But Revit is a product of the Autodesk. For example, I've been in Bentley Systems for a couple of years in Australia. There we had the open building for the BIM software, and also for the animation, we had the Lumen RT to animate the project like this. So it's similarly, we have the Autodesk equivalent and similar products. Here I use the Twin Motion, which is a free software. And this is the explosion feature that they just added in the recent update. And I just used how to break down the elements and how to put back together, trying to visualize what it means in terms of the elements, how we put together, and how we transform the point cloud to a Revit model. Make sense?
Yeah, yeah, absolutely, yeah.
So yeah, that was the, well, long story short, in terms of the Scan-to-BIM. This is another project. You see me on the field, and this is Sunshine Beach in Queensland. So the project was an architecture, and they just wanted to renovate, actually knocking down the building here and then build up. But they needed a full visibility of the environment because that was on a hilly side of the beach, and also many villas here in the very proximity and vicinity. So they needed to know, the architects needed to know exactly in terms of the visibility. So I started from the drone, and then you see me on the ground with this scanner, with the 360 camera on top of that. And you see me on my phone, on my wrist. I have the full visibility. I have the real-time point cloud. So on the fly, I'm looking at the gaps. I'm looking at the point clouds, and I'm collecting in real time. And this is like, this scanner is collecting 200,000 points per second. Yes, and those points have X, Y, and Z coordinates, and also the RGB colors from the camera, colorizing the point cloud. Of course, this is the false color, and you see two layers here. One on top, getting from the drones, and you see how it sits on top of the yellow one, which I got from the Islam scanner. So it's capturing indoor space, corridors, rooms, internal geometry. Each technology has its strengths and limitations. I mean, the drone and SLAM scanner. So the drone cannot see inside. Everything can be seen from the above. And the indoor scanner is really complementary solution, which cannot easily capture the rooftops or above. And so they play together, they co-play. So the real value coming from the combination, how we combine them and how we merge them or make it a fusion, let's say, if you will. And this is called a sensor fusion, if you will. And bringing them multiple capture methods together and how to blend them in a meaningful way, this similar, aligned accuracy to create a more complete understanding of the building for architecture, and this means better existing condition documentation and more confidence before design decisions are even made. So this is providing full visibility in terms of the environmental, or let's say spatial awareness. I like this term that we use a lot. Spatial awareness is pretty much providing the full information of 3D space, but still some small element is still missing and lacking, and I will tell you what in the next slide. So exciting game, right? So this is really my
That is
passion.
very exciting. Yeah, I wish that we could do the same thing for our building at Curtin campus. Probably
True.
next year we need to like get in contact with you and hire you to do some of Curtin buildings as a case study. So we have this in our file and our archive for the students.
Yes, it looks like you're having all the fun. And we'd like to have some of that fun with the drones and devices.
Yeah, exactly. So rather than I tell you how, I provide you fish, I just tell you how to fish. Perhaps makes sense. And yeah, I'm more than happy for both. Well, depending on. So then it brings us to another noisy slide here. So when I was talking about a missing element of the full visibility, and this is really a visual contextual information. So having that 3D space, point cloud, everything in geometry, which is really super nice deliverable, we still need some contextual information to complete that big picture of full visibility. And that's the visual coming from the panorama images or virtual tour, if you will. So starting from this scanner in the site, walking the site, slam scanner, depending on of course, the accuracy we need. If you are talking about for example, some just a holistic view for you down a demolition project, we do not really need a super high accuracy. So we normally, this mobile scanning, which is around the 1 to 2 centimeter accuracy. But when it comes to the design, we need less than 2 millimeter accuracy. We need to use the tripod scanner. So the playbook is really depends on the purpose, fit for purpose, and also a scope of what's eventually we need to deliver. So, but for all of them, either we are using mobile or tripod, we nowadays use a 360 camera or spherical or panoramic, you name it. It's simply providing the full spherical imagery, high-res images. And so when we walk the project or we stop and go with different scanner at different floor, different levels, or very complex situation, we provide full 60, and then we can use a goggle and digitally walk through the projects and have the full visibility no matter where we are. We can remotely do this. And this is really awesome project when you can provide not just a link to this project, and you can walk it digitally no matter where you are. So you can, you just imagine that how you can expand the collaboration between different teams located at different locations, so across Australia, even globally, and how we can pull many teams together on one virtual room and discuss about the project. So you can all digitally walking the project. You can even measure in terms of the design. Sometimes you need to measure things. So by goggle or by virtual or augmented reality, a lot. So a BIM modeler can use it to interpret the point cloud more confidently. So point cloud is a bit fuzzy, it's a bit scary, and sometimes it's like a nightmare. When it comes to the very complex projects, it's really like a nightmare. Even colorized point cloud doesn't provide you full visibility and full comfort to identify the elements and also interpret them. So a BIM modeler, which is sitting and want to do this project, this Scan-to-BIM transformation, can use it to interpret the point cloud. So when if something is vague and also unclear, just turn on the full virtual tour, and an architect can use it to understand the space, proportions, materials, and design context. A client and or any other stakeholders can walk through the building remotely without needing to physically visiting the sites, which is really mitigating the risk of the sites if it's a bit hazardous sites, for example. And this becomes a bridge between technical data and the human understanding. And this brings me to even more exciting part of the slides. You can, if you can scan this code, or if you have the access to the chat, you can click on the first link that I just provided in the chat. I hope it's still there. I mean, it's still the link.
Yeah, the links are there, still there, and we can see. I just scanned.
If you are on a computer, you can feel free to click the first link, or if you are sitting in the room like professors in this room, feel free to use your phone and scan this QR code. And then we jump to another, I'm trying to exit from this. Okay, and switch, allow me to stop sharing here. I want to, share another screen. Just a little bit.
Okay.
Allow me share screen.
Oh, okay.
Okay, I'm sharing the screen. So I hope that everyone is on the same page. Are you looking at the same environment on your phone? What do you see?
Yeah, so I see almost the same view, like the street view of
good.
What you're
so
showing.
This is a live demo. I'm not on slides anymore. And this is the link that you just clicked or you just scanned by your mobile phone. So again, as I said, I will share this presentation, a limited version of this presentation, perhaps not full videos. The videos will be available on my LinkedIn page. The slides and the contents are, and also the links are available, will be available for you too. So this is not just, perhaps you've already seen some of the virtual tours when you can walk through providing the visuals, but we have beyond the visuals here. So what you see is we have a list of the points we can navigate through the sites, either by some visual footprints, clicking on them, or just simply going to the list of the different waypoints if you want to jump here and there. And if you want to, this is the same project that I showed you of scanning, and this is providing the full visibility. So just imagine that I'm in the point cloud in such a complex environment, very vegetated and also forestry environment. I can even access the point cloud here. On the top right, you see menu, a pull-down menu, and I just click on point cloud, and this is the point cloud. So even on your phone, you have the access to the point cloud. So you see how easy and it is to share just a link to anyone, even by a text message. You can provide the access to this job site. So when I'm still on the job site, I can share this link to anyone in the world, literally providing the access to the both point cloud. So I'm on point cloud, and something cool here. And guess what? You can even measure things here. So just point, for example, I just go here, I snap to one of the points, and this is the national coordinates, Australian MGA 2020, in terms of the horizontal reference frame, and the height elevation is AHD, Australian height datum. So this is a national coordinates. So no matter where you are, no matter it's sitting in the real world, in this exactly this in terms of the ground truth, you are looking at the national coordinates in Australia with the local national coordinate system. You can even measure distances. So again, everything is on the cloud right now. So I'm not using any software on my desktop or on my phone. The heavy lifting part is processed on the cloud. So even with any device, no matter which device, no matter which processing unit, you can easily handle such massive data, millions of points, switching between point clouds. And in terms of the interpretation, if something is unclear, you can simply switch back to the walkthrough and look at the same spot. Yeah, we have a box here, we have a garage here, and everything is even measurable in this space as well.
Mandy, I've got a couple of questions.
Okay, feel free.
One is this what you meant by the tolerance of 20 millimeters, 2 centimeters, as opposed to the 2 millimeter? So is this the measurement that you were speaking of earlier? The accuracy measurement. Is that related to this?
Actually, this is really, we look back to the stage when we are planning to do this. So with end goal in mind, from the beginning, we really need to pick up the playbook. We need, depending on the accuracy we are looking for. For example, if we are looking at the scope of a project for construction, we should be around 2 millimeter, not beyond, not more than that. Yeah. Then we use the terrestrial laser scanner on tripod, stop and go, and we are in the same environment, but we are around 2 millimeter accuracy in terms of the relative accuracy. But
so what you're saying is to gain this for this 360 virtual site capture, if it's done with the wrist camera, you'll be closer to 20 millimeters accuracy. But if you use the tripod, you will be closer to the 2 millimeter tolerance and accuracy. Is that correct?
Yeah, it's correct for the point cloud only. So when we, for example, when we coordinate some points, for example, I snap, let's say, on top of this pole, for example, the accuracy I get for this coordinate, it's around 2 millimeter if I'm using tripod scanners, and it's around 1 to 2 centimeter if I scan this project with the mobile scanning SLAM scanner.
That's really clear. Thanks for confirming that. My other question was, I know that we can collect this data by other means, but does this, when you pan out, particularly with the drones, is there a means by which you can also collect the contour data as well?
Exactly. Yes.
Of the site?
Exactly. So the contour data is simply just a deliverable of the software that you're processing the whole data set. But nowadays, the contour lines also are not really needed. Just a visual presentation on 2D, it makes sense. But it doesn't, it's not really the base for the calculation anymore. For example, for volumetric computation or calculation, it's not really nowadays required to use the contour line as the base. So it's more, it makes sense only just for a holistic view of the job site, for example, just to have a better understanding how, in terms of the elevation, it's representation of the third dimension in 2D maps.
Yeah, it's absolutely superb for someone who goes to site and takes out a tape measure and measures everything. I think it's a superb way forward.
Exactly. You can even measure the wires here on the transmission line crossing. For example, if you just want to design something and it matters, you need to know the height of these wires crossing this street. So 6.79 meter is the height of this wire. So looping back to the visual, this walkthrough is not meant to be the base for the super accurate measurements, but it provides you the full visibility in terms of the interpretation. So this is, even if you have the possibility of measuring things here, but if you really need to the highest accuracy, possible accuracy, you need to use the point cloud, because you can snap better. This is a really more accurate base for measurements. Make sense?
Yes, man. Yes. Yep.
Perfect.
So let's keep going. We have almost 15 minutes left, so we want to have maybe another 10 minutes of.
So I try to. So yeah, I just lost the time. Sorry. So I stop sharing here. I go back to. I'm trying to go back to the slides that I had. All good. You see the slides?
Yeah.
Yes.
All good. So yeah, laser pointer. Yeah, I just need to make sure that I will cover everything. So this is another project in Perth. These are the gadgets, as I said. So again, flying the drones over asset, I try to make it a little bit quicker to catch up the time. You just be conscious about the time. So again, same scenario. So aerial images. This is the tripod scanner, because we needed 2 millimeter accuracy in terms of the renovation of this space, and also ending up with this point cloud of this site. And this is the animated section providing more visibility in the point cloud, which looks fuzzy. Also, this is the virtual tour we get from the panel camera on top. So sometimes tripod laser scan is needed because the project requires higher accuracy. This is why fit for purpose is very important. So because reality capture is not just about buying a scanner or using a scanner, the method depends on the project need, accuracy, time, access, budget, risk, and deliverables. So in this case, we capture the data supporting the modeling and renovation, planning, interior design, understanding the full, and also helping the decision maker. And these two sections, as you can see, extracted from 3D model, not on the other way around. So some people start from 2D and then try to make it 3D, which is a little bit friction here, but it's more hassle-free if we do it on the other way around, extracting the 2D sections from the 3D. This is a new technology. This is providing another link in the chat on also QR code. This is very actually processing intensive. So this video is showing a new technology named 3D Gaussian splatting. This is a newer technology than the previous one, which was photogrammetry. And it's really it's more visually pleasing, more crispy, and more high-res, super high-res visibility. And I do not try, just to be conscious about the time, I do not do the real-time part. So feel free to use the scan code and also the link, and also navigate yourself. You can easily walk through with this impressive level of details and visualization, as you can see in this video. So, but just remember that this is a different, newly developed, named 3D Gaussian splatting, or in short, 3DGS, a new technology based on the AI. So in terms of the next level, it brings us to the MEP side of the BIM part, the mechanical and also the engineering, piping, HVAC systems, the heating, ventilation, and air conditioning part. And it's really needed to be added either in the way of the BIM, actually putting together as a BIM model, or by scan, because we need to have all elements of a building or any structure to end up with a complete digital twin. Otherwise, something big is missing in operation and simulation of the whole project. And when it comes to this part, also then we end up as the most complex aspect of the project, which I reckon it's the MEP and HVAC, which is the proficiency of Amin, and he has more to present. So it brings us to the idea of digital twin, and I really love to demystify and correct a misconception here. Sometimes some people believe that a digital twin is just a geometry or a BIM model, but it's more than that. So digital twin is really a replica of a project. And when we say a replica, this is replicating all of the situation in real time and monitoring the enlivened model and live data. It's not, rather than being, just having a reality capture or a BIM model, we are looking at a living actually creature, which needs to put IoT sensors in place, temperature, environmental, pressure, whatever which makes sense depending on the asset, depending on the operation and type of the asset. So we need to have IoT sensors in place. For example, for HVAC systems, for temperature and pressure, you need to have gauge on the asset. And then we scale up to the city level. This was the presentation that I had last year in Spain for Smart City Expo conference, how we can create a digital twin at scale, at the city level, city scale, and how we can do the better management, the smarter management in terms of not only, rather than doing disaster management, even if we have fast responsive to disaster management, we are more have in a predictive environment where we can predict the disasters and avoid them, which is less costly, which is mitigating any risk and also improving the safety. So we are looking at the dashboard right now for the city management, where all of those IoT sensors, occupancy of the parkings or any temperature, water level, you name it, any sensors in the city, traffic sensors, which is providing the live data coming from SESA and projected in your dashboard. So you're looking at the whole city, you see like a heat map, which you can identify the hotspots where you have problems for sending emergency, for example, forces or any other situation, even forecasting. So you are creating a time travel machine. So rather than just having the history of the data of each building with the BIM data and whole city, you can travel through the time. So back like history data which you already have, and with that data in the system, you can even travel to the future. So you can predict the situation. So for each asset, you have the manuals for the maintenance, for the operation. So you can predict that at which certain point you need to do the maintenance, and that will be considered as predictive maintenance. So being proactive and just, rather than being reactive, you do the proactive maintenance and predictive maintenance, let's say. Well, with that said, on digital twin, enough said with that demystification. I just end up here with the takeaways we can get from this presentation, and I would like to highlight 5 key takeaways and try to highlight the return on investment on the whole stories, that we are not doing this for the sake of the digitalization, and what's the catch in it, and what's the return investment. So capturing reality is really cost saving, time saving, labor and resource saving. We can do more with less resources, human resources or materials, quality improvement, and risk mitigation. And then in this part, accelerating decisions really makes sense. Again, this ROI is really time saving, also labor saving, cost saving, and productivity improvement. And tracking in real time, how we can track the project to make sure that we are on time and on budget, how we do the progress monitoring. So in the collaboration with the team, it's really eliminating the friction between teams, how they can perfectly align with each other in collaborative environment. Even on the cloud, they can easily see if someone is on the ground, do the clash detection, and then it's in real time will be project in the cloud, and everybody else which is related to that project is informed. So it's really informed the decision making. So, and hopefully the promised land is really this green part, which are environmentally actually friendly. When we, in terms of the decarbonization, how we minimize the footprint of the carbon emissions, hopefully with the zero emission initiatives, how we can do the zero carbon projects, life cycle, cost savings, and resource efficiency and quality improvement, which is eventually, hopefully, ending up to increase and improve the quality the quality of life, And that's pretty much end of it. And it brings me to the Q&A session.
I like the way that you presented the setup. If you, yeah, that is his information. Please, guys, if you have got any question, if Mehdi is free, yeah, he would be happy to answer your questions, and you can ask your questions to me and I can transfer your question to him. But now I let the students to ask the questions if they have some questions for a few minutes, and then Alina probably has a few questions as well. So let's start with you guys. Who is gonna be the first?
I hope this session gave you a useful glimpse into how.
Definitely.
Hi, Amin. Hi.
Hi.
Could I please ask a couple of questions just really quickly? Your slide on level of development. In building design, we were told that we should only draw plans to the level of detail of 300. But from your slide, it looks like we should be drawing to 350 so that as for like specifications for the consultants. Could you clarify if an architect, an emerging architect, should be drawing to possibly 350 to provide specifications and clear instruction on how the plans are drawn or built?
That was the first question?
Yes. And then the second question was in regards to building and construction, if you're doing LiDAR scanning of an existing building, if you find different places that might cause issue, do you do any kind of impact studies before you go ahead and execute the plans?
Well, thank you very much. Excellent questions. In terms of the first question, I've seen this. I've done a little bit research. I'm not expert in this BIM modeling and LOD part. I've just done as much as I needed to have a better understanding in terms of whatever and the depths of I really needed, not more. But according to my understanding, I've seen that different standards. They jump. There is no 350 in some of them, if you mean that. And but according to the standard, and there is a standard in Australia for the BIM, I forgot the ISO number. It's a 5-digit number, if I'm not mistaken. But according to the latest, which is aligned with different standards, I've seen that this LOD 350, which is the definition I've put here as the interface and connection or detailed connections and interfaces, a little bit more detailed than it's between 300. So why it's 350? Because it was not in the initial plan, and then it was decided that it makes sense to be in between. That's why it's 350. That's providing more details in terms of the connection. Sorry, I don't know more about this. Maybe professors can help me with that.
Yeah, actually, for her first question is that like, to what level architects need to be involved, like almost all of it, because you start from the first level, which is 100, which is massing design intent. So you would be updated in each level of the project based on your need and to what level you need to do in your work and your assessment. Probably, yes, you can say in level 350, that is something that we are looking for, but maximum, not more than that. And based on the need, based on the project, let's say if I am working on previously I have worked on a steel factory project that I had to kind of engage more in details of the project, manufacturing process and installation based on the need of the project. So sometimes people ask in what level architects needs to know this information about electrical, plumbing, HVAC systems. Depending on the project, sometimes you have to even update your knowledge. You have to have some studies before that. You need to, sometimes we had to ask people that they had different courses for us to engage. But it is not something that you necessarily need for every single project. For more detailed projects, for high-rise buildings, for commercial buildings, yeah, that is something that is more than enough if you get to that level.
Thank you. And for second question, when it comes to the scanning and when something pops up and unexpectedly and there's a surprise that this should not be according to the plans, it wasn't meant to be here, for example, if you meant this point. So that's not our job to do something for it. Our job is just to reflect the reality. So in terms of the reality modeling or reality capture, if you will, so we just, you know, our scope of work in terms of the as-built mapping is just to reflecting the reality and back, you know, reflecting back to the as a deliverable. This is the reality. So no matter what's in there, this is what's there. So in terms of the reality, with all details, all, you know, nuts and bolts that we provide, this is happening. This stone was there. This wall was not there. And so we just provide the full deliverable as the digital copy, 3D copy of the existing situation, and that's there to decide what to do with what. So I hope it makes sense that
Thank you.
signers,
Yeah, no, it was more
planners,
about delivering return on investment. So if you're going to be doing a remodel or construction and you locate an issue, your recommendations could be sort of, this is how I would build it up. So thank you, though. I don't want to be.
But another good takeaway for you guys is that the way that he put his presentation slides, it's very useful because like you don't see many words, but it is good enough and it is easy to read and it is just well organized. So I have one question. Anybody else has questions? Let's see if any of the students has other questions. Okay. So in terms of, sorry, I start quickly with my first one. In terms of softwares that the students, or especially this page, yes, Maddie, thank you for sharing that one. If everybody had a takeaway page like this with enough image, text, and good references as well, would be perfect for our unit and for our assessment. Is there any software or AI maybe that you suggest students to learn apart from architecture or software, let's say Revit or something like that, that helps them when they want to plan or show these systems, let's say different systems in their work, in the architectural drawing, that is more accurate? Let's say if they are using any AI, usually they assume something and then they go with that one, which could be wrong, which could be correct. What is the best software or AI that is more accurate?
Well, in terms of the accuracy, we are, as surveyors, we are very obsessed about the accuracy. So we not only, we have a saying that we learned from the Russian politician, which trust is good, but control is better. That means that nothing is acceptable without verification. This is in our surveying world. So we have to verify everything. We just need to assume that everything could go wrong, and we just need to double check. We always need a plan B, and we all actually, but in terms of the deliverable and accuracy, there will be no plan B. So it has to be 100% verified accuracy. So we cannot take any risk around that. So back to your question, in terms of when it comes to the AI, I have never heard any software which can reference very accurately without any hallucination and without any fabrication, let's say. So they all fabricate at some level. They all hallucinate in some level, even when it comes to the geometry. I've heard that in the recent update of Revit, they have leveraged a lot of AI, but I don't know much beyond that. And I'm very mindful to leverage that technology when it comes to the design and also the dimensions, everything else. It's good to, please people, to create some impressive visuals. But when it comes to the drawings, I'm very conservative around that.
Yeah. Okay. Thank you. Yeah. Thank you so much.
I have a couple
Perhaps
of
it
questions.
was a warning. Yeah. Sorry.
Yeah.
Have we got time for a couple of questions?
Yeah, we can still ask some questions. I
have,
some of our students are actually doing, their section is on smart and real-time technology. So my question is regarding sensors and where the sensors should be placed within the building, any preferable inside and outside. I know outside might be a different system. And where would the actual management system, any ideas on where best to locate a management system for the likes of the collation of data from sensors? For instance, better near switchboards, better in a plant room and switch situation, or even more accessible via the office spaces. Where do you recommend, A, for sensors to be located, and B, for where the management system to be located?
Well, excellent questions. Thank you. In terms of the facility management and also what we are looking for as a catch in the digital twin, this is meant to provide you the full visibility as holistic view in general speaking. And when you want to break it down to the best practices, where to put what in terms of the sensors, wherever it makes sense, depending on the general answer is wherever it makes sense. And to break it down to more meaningful answer, I could say, for example, what we see as the HVAC system, for example, depending on the asset that we're looking at, for example, the building management needs to have a full real-time visibility, and even not with the human intervention, even if the operator is not at work, it has to be 24/7 monitoring, connected to an early warning system, like a fire system in our building, we have sensors for the smoke sensors in the rooms. For example, in my apartment, we have smoke sensors, which is super sensitive for any smoke as a sign of the hazard. Could be fire, could be anything, or overheating something. And that sensor sends a message to the central system, and it activates the warning, the alarm, evacuation alarm, whatever. So without human intervention. So what I'm saying is that it has to be, on autopilot, on autonomy, all systems working together in a smart way. So even with or without the human sitting and monitoring and looking at the hundreds of monitors, looking at different assets, HVAC here, rooms there, corridors, or whatever, air condition, cooling system, whatever. So it has to be automated. And in terms of the location, which sensor where is the best, it really depends on the asset we are talking about. For this example, it makes sense if you put, for example, pressure, water level, I don't know, the temperature sensor. Maybe Amin can help me provide more.
Yeah, it definitely depends on the type of the building and the access. The first important thing that they need to notice is the access point, which is, let's say, if it is a tower, it should be, let's say, if it's a high-rise building, most of the time they could be in every few floors, and this main central point is somewhere which is in the basement or ground floor, or at the top as well, which you need to have access in terms of emergency. So most of it goes back to the emergency control systems. So let's say something happens in terms of fire or any hazards, it has to be accessible and it has to be very safe and secure. And in some buildings, we have multiple plant rooms based on the function, like especially in high-rise and commercial buildings, we are talking about multiple plant rooms. But there is one central plant room or control system that is in the most accessible place. And as I said, it is completely different from like building to building, let's say hospitals, offices, educational buildings, and design of the building. If the building is, let's say, very wide, or it has an H shape, or it is like a linear plan, then it should be somewhere which makes sense in terms of accessibility. That is the most important, like something that I can say in my understanding and whatever I have seen through the projects. But this is the architect's job to design that room. How you design it, you have to talk to different engineers, mechanical, electrical, all of these engineers, and then they might have different suggestions or things that you are not aware of as an architect. So they might say, okay, I need this much space for this room. I need to have like a separate room, maybe outside the building. So that is where you need to collaborate with different engineers in terms of design. But definitely that comes to the design and architect's decision at the end.
I actually think that slide where you said placemaking was really important for our students, because they could be placemaking for where they think that, looking at the building sectionally, and for, as Amin said, easy access to a number of floors within a number of floors. But also just to be able to write a note for those of you who are doing that section, to be confirmed by engineers or mechanical engineers. So you can always write that note as architects, just like we write C engineer specifications. You would write C, because essentially you're placemaking where you believe it to be the most suitable place for that building and that building type. And I really like the example of the fire sensor, because that's absolutely right. It's actually put up high because the heat will rise and the smoke will rise, or smoke detector and heat detectors are different, but they're always up on the ceiling. So they're immediately able to capture that information and send it through, as you said. So any of you working on sensors, just have a think about fire and heat sensors. I have one more quick question, and it's about because all of this reality, real-time is capturing information above ground. And I was wondering how close we are of using the likes of GPR, the ground penetrating radar systems, to have a look at what is happening below ground, so that we can maybe predict shifts in things like the level of compaction, if that's becoming compromised under a building, or perhaps changes in aquifers or movement in water. I'm wondering if we're looking at information above ground and how that affects the building. Is there a way of using the available technology like GPR to document what's happening below ground as well? Because I know at the moment GPR is more of a location system, but I'm wondering how much real time there will be, and if we're looking at it, because I think that would be great.
Well, that's really excellent aspect of the looking at this, because sometimes what we try to hide what we do not see, and that's the mysterious world part of the aspect. Half of the world of construction is the foundation and the geology, subsurface, and that's when I was at Bentley Systems. Maybe it's worth noting that they just actually took over a company named Sequent, Bentley Systems, Sequent, with 700 people focusing on geology and subsurface structure. And the company, that the deal was $1.4 billion something. Bentley System actually realized that that's very crucial part of any infrastructure, to have a full visibility of the subsurface underground, as you said, properly. And in terms of the GPR, or ground penetrating radar, which is providing the scan of the subsurface, but of course the graphs are not easy to interpret. With some specialists, very experienced specialists, has to be interpreted. And I've never seen any type of real-time GPR, and maybe I doubt that it's necessary. If you do this frequently, maybe that's not really fast process. I'm not expert in that space, but I've just been exposed to the subsurface with the GPR when it starts with the infrastructure more when it's the super heavy infrastructure like bridges, like big towers or skyscrapers. It's really crucial to have a full understanding at the certain depths, like 40 meters, 50 meters, or even more. And if it's much even beyond the range of the GPRs, because the trolley GPRs cannot reach over the 6 or 7 meter depths, but then it goes to sample core sampling more. They just drill and then do the core sampling for the geologist. And at Bentley Systems, our solution from Sequent was to do the geologic modeling out of the core sampling rather than being on GPR, which is like a scratch on the surface of the underground below just a few meters. They needed much deeper understanding and modeling of the subsurface. I hope it makes sense.
Yeah, the core makes sense for sure.
Sean, do you have? I have another lecturer with me online, Sean Banner. I want to know if he has any questions. Sean, do you have any questions?
No, it's all pretty clear, informative.
Okay.
Great to see how the technology is being implemented. So, thanks very much.
Okay, yeah. So I had one question, just might not make sense, but let's say for a project that you are...
There's no silly questions, right? There's no silly questions.
Let's say for a project that, let's say one of the buildings that you have showed us, like at the, let's say Perth case study or the one in Queensland. Let's say if a client wants to do that or get this project 3D scan with your technology and model, like financially, and let's say, what are the numbers that we are looking at? If they want to go through this step, because one part of it is that, like, if people are willing to spend that much money for a project like that, what are the numbers, just for my understanding, that we are looking at?
So in this project, we are looking at a $5 million property. It's just very average, even below the average in the Sunshine Beach. Expected property value. And there's the service that we provided there, which was a modern service. They just assumed that this is the highest technology in place to provide them the super accurate, full visibility of their project, which was correct. Our fee for doing this job, you see me here, less than a day job on site, because you see that is very, very fast scan, and also that was all fun, to be honest. That was not a work for me. And so less than a day, and then a few days processing and creating the deliverables. They just needed some sections and some 3D. They also needed the AFC model. So we created the Revit model, and then we converted to IFC model, which was more standard across the. They wanted to use the ArchiCAD. And I did a little bit research. I realized that the ArchiCAD could not ingest the Revit model. So I exported an IFC model for the ArchiCAD to be able, for enabling him to be able to process it. And also provided some sections like this, as you can see. The whole fee was like, for us, it took 1 day operation, less than a day on the field, a couple of days to, a little bit more, 3 days, because Revit model was a little bit time consuming. It was a manual job to do. It was totally, the fee was like 7-8K.
7-8,000.
Aussie, yeah.
So they would rather to pay a fee like that to get the information that they want in terms of accuracy of the project and whatever is available, and then probably for the future design or what are the changes that they want to apply to the project. Okay. Well,
of course, we had some, if I do not provide a biased information in terms of the best of the class, we had more customers when they heard about even a few $1,000s, they decided to do this tape measure instead. because they didn't see the value, or we couldn't do the value proposition properly, or they just didn't see the value, or it was not worth for them, even for multi-million-dollar properties. And that was a little bit. We decided to do this better in terms of the value, to highlight the values.
So one one thing that I can see here is the time, because if you want to pick all this information, put it to Revit or any software, it takes probably a couple of days. And there would be, because I have done this multiple times, I have in my especially renovation projects, and sometimes if you do one mistake, that mistake costs you a lot of money and a lot of time. And let's say within 3 or 4 days, you can do everything done to the Revit model from what you pick on the side. That would be, I think, the best part of it. And that is the return of investment, I think, for that one. It is accuracy and time saving.
Yeah, in terms of the time saving and also the improving the accuracy and to eliminate the possibility of rework and mistakes, which is even more costly. Sometimes we do not understand why they do not save, because the return on investment is much higher than the investment they're doing in this type of reality capture to provide them, to save this. But this is the work, happens.
Well, it was a very good presentation, amazing presentation, Mehdi. We are at the beginning. As I said, this is the beginning of our collaboration, and also this is the beginning of also this kind of technologies. But this is something that students need to know more about it, and they need to apply to their work. This is the new world, new era. Everything you guys need to be updated all the time. Doesn't matter for me myself. The experience is one thing, but now you have to be on track, because it's like a river. You have to go with the flow. You can't stop at any time, because you would be behind everything. So that is, I need to update my knowledge. You need to update your knowledge. Everybody needs to update. And
this is endless story. The learning curve is really endless. So feel free to scan my LinkedIn code. So feel free to ask more questions. I will share the YouTube. I mean, I've already shared to you, so you can share. Feel free to share across the students and also the team.
Absolutely.
They
can go and follow Mehdi on LinkedIn. And thank you so much to join us and giving your time to us.
Thank you very much. I'm giving you a clap if you can hear that. Thank you so much, Mehdi. That was absolutely superb.
I'm glad to hear that. Have a lovely day, guys.
Thank you so much. Thank you.
See you next time.
See you. Bye.
See you.